Okay, so for this problem here, the suitable hypothesis, as you said, is that mu is going to be 90 and that the alternative is not 90. Now, when we think about this, we do not know the true standard deviation, right? We do not know sigma. So we know it's going to be a t distribution. So if you look at the calculator, I've put the values in here, and hopefully I didn't type anything in wrong. I'm going to go to stat, and I'm going to go to my tests. And because of it, it's going to be a t distribution. I'm going to do a t-test, and I'm going to use the data as opposed to statistics means I actually have the stats that I can add, but I actually just have the data. And so my mu is 90. And my list is in L1, the frequencies are L1, and I want a two-tailed test. And then I hit calculate. And then I can see that the p-value equals 0.0455. And so now I'm going to justify the choice of test. So what I'm going to say now is I'm going to do, since the p-value is less than alpha, so it's small, we reject H naught and claim sufficient evidence to support John's claim that it is not 90 seconds to open laptop. Okay, now then it says justify your choice and include any assumptions. Well, the reason why I chose the t-test is because we do not know the standard deviation. We do not know sigma. From our calculator, we can see what the S value is. The S sub x is 8.45. This is the unbiased estimate. And so we have to use, t because we do not know what sigma is. Well, the next thing to think about is like each of these particular times to open up the computer, are they independent of each other? And I would probably argue that they're not independent. It's hard to know, but that is an assumption we have to make. The other one is that because our sample size is only 10, we have to assume that the time to open up his computer is a normal distribution. Okay, if the n would have been bigger than 30, then we wouldn't have to do this, but we have to assume it is a normal distribution. And there we go.